Section 3.3 deals with similar figures and scale models. So I know you spend a good bit of time on similar figures in the geometry section for 7th grade, so you might be familiar with these. If not, this will be, or if you are, this will be a good review. If not, make sure you take really good notes on these different things. So there is a little bit of a lesson opener. I'm just going to scroll through it. You can write down your answers, pause the video if you need to, and just try some. So we have x to the third equals 64. Well, we're thinking, what can I multiply by itself 3 times to get up to 64? That would be 4. Next one, 49 over 64 equals x squared. So we're basically taking the square root of each of those numbers, and we get 7 over 8. 27 over 8 equals x to the third, so we're having to take the cubed root of 27 and the cubed root of 8. X equals 3 over 2. And finally, we'll have to follow our order of operations. So first we'll have to square both sides, or not, it's not both sides, but the numerator and the denominator. Then follow our order of operations to solve. You get x equals 2. And then 1 over 8 equals x to the third over 14. So you would have to cube the x and the 14. Then you could use cross multiplication to solve. You get x equals 7. So into this section, we have a couple definitions. This starts on the page, bottom of page 105. So similar figures have the same shape, but not necessarily the same size. Similar polygons are polygons in which corresponding angles are congruent and corresponding sides are proportional. We use this little squiggly right here to mean similar to. So for example, we would say triangle ABC is similar to triangle XYZ. Corresponding vertices must be written in corresponding order. So that means we would have A is corresponding to X, B is corresponding to Y, and C is corresponding to Z. It's important to pay attention to the order. So if triangle ABC is similar to triangle XYZ, this is what we were just saying here. It means angle A is going to be congruent to angle X. Angle B is going to be congruent to angle Y. And angle C is going to be congruent to angle Z. And then segment AB is congruent or is similar or proportional to XY. BC relates to YZ, and CA relates to ZX. And it might help if you just draw out a triangle to see that. So just real quick here, if we drew out this triangle and this triangle, we can say that they are similar. We have A, B, C, then we would have X, Y, Z. And that helps you to see the angles that are congruent and then the sides that are congruent and how they have to be written in the same order to show that. Okay, so for example 1, it says find x, y given the measurements of the 2 similar triangles. So it gives us 2 triangles. It tells us that they are similar, which means they're same shape, different sizes. This side is 5, this one is 5.7, this one is 2.5, and we are solving for m. And this is C, A, B, X, Z, Y. So we want to set it up CA, so here's our side CA, so that'd be 5. And it's actually over ZX, because we see this is ZX, so that's a typo there on the slide, so this should say ZX, which is 2.5. And then our AB side is 5.7. And the side we don't know, the XY, that is M. Then we solve using cross multiplication. So we have 5 times m and 2.5 times 5.7. Plug those numbers into your calculator, you get 5m equals 14.25, and then finally to get m all by itself, you just divide by 5 and get m equals 2.85. So the important part is to remember that you have the corresponding sides on top of each other and the same triangle on the top and the same triangle on the bottom. These could have been flipped around the opposite direction as long as it was consistent. Maybe we would have done the smaller triangle first and the larger on the bottom. That would have been fine also. We'd still get the same answer, but just stay consistent. So you have the related triangles right across from each other and the same sides on top of each other. All right, so example 2 says if segment BC measures 7.25, find n, then compare the ratio of the triangle's perimeters to the ratio of their side lengths. So first things first, we have our 7.25. We're finding n. And we can choose either of the sides since we know segment AC and AB and XZ and XY. So we can just choose, they chose this was AC and this was XZ. Then solve using cross multiplication. Plug those into your calculator, divide by 5, and you get n equals 3.625. Now that we know all the sides for both triangles, we can say the perimeter of ABC and the perimeter of XYZ. So we're going to add up all the sides for A, B, C, add up all the sides for X, Y, Z, write them as a ratio. So we have the perimeter of ABC over the perimeter of XYZ, divide that out, and we get 2. So the ratio of the corresponding sides is 2. And first, that was for perimeter first. We did perimeter first. And we're comparing it to just doing two sides. So if we did CA and ZX, 5 over 2.5, we still get 2. So for the sides, it is also 2. So we should see a relationship there, that the ratio for the perimeter is going to be the same as the ratio for the sides. So you might want to throw that into your notes real quick. And that is just this. In any similar figures, the ratio of corresponding lengths, including perimeters, is equal to the ratio of their corresponding sides. So example 3 says it is convenient here to convert the lengths to feet, so we must be working with two different things. Yeah, we have inches and feet going on in our problem. So it says find the height of the flagpole. If it casts a shadow of 76 on the ground, now you'll get a lot of word problems like this. It's helpful to start to draw things out. So here's my flagpole. And it has a shadow that is 76 feet. And we also have a person right here who is 5.25 feet tall, or it told us 5.3 feet, or sorry, 5 feet 3 inches. Well, 3 over 12 equals 1 over 4, which is 0.25. So 5.25 feet tall, and then 1 foot 6 inch down here. Well, 1 foot 6 inches, 6 over 12 is 1/2, and 1/2 is 0.5. So this is 5.25 tall and 1.5. And essentially what we're making here is a triangle. And they happen to be similar triangles. So once we've drawn the picture, now we can go ahead and solve for what is the height of the flagpole. And there's the information they just gave us. So here's our equation. We have h over 5.25. That's our first ratio. And then we have 7.6 or 76 over 1.5. You'll notice we have the flag information on the top and our person information on the bottom. And then we will just solve using cross multiplication. You end up getting that the height is 266 feet. So in any similar figures, the ratio of their areas is equal to the square of the ratio of any two corresponding sides. And in any similar figures, the ratio of their volumes is equal to the cube of the ratio of two corresponding sides. So far we've been doing side over side equals side over side. Now we're going to start saying the area of our first object and the area of our second object equals one of the sides and its corresponding side on the other object squared. And we can say the volume of the first, and the volume of the second is equal to the sides cubed. So that's volume of the first and over volume of the second is equal to the side of the first over the side of the second cubed. So those are our two different formulas for area and volume of similar figures. So example 4, which is on page 108. So the ratio of lengths is 2 to 3. That means the ratio of the areas would be 4 to 9. So what we're doing, we're just saying, okay, well, if it was 2 to 3, then the areas would be 2 to 3 squared. Well, we have to square the 2 and square the 3, which would be 9. So that's where they're getting the 4 to 9. And the volumes, so same thing, we're taking the ratio of their sides. Now we're cubing them. 2 to the third power is 8, and 3 to the third power is 27. So that's where those ratios of volumes are coming from. To find the area of the base of the larger prism, so the problem in our book, you would have to go through and read it. It's really long, so I'm not going to read it. You can pause the video to do that. It's all related to what we were just talking about. So this time, they're telling us, okay, well, use that ratio then. We'll tell you the area of the smaller is equal to 36, so find the area of the larger. So we would use 2/3 squared, which is 4/9. Remember we said that was A1 over A2 equals side 1 over side 2 squared. So we took our sides, we squared them, we plugged in our areas, now we use cross multiplication to solve. And we would get the area of 81 units. And then for the volumes, same sort of deal. They're telling us this time that the volume of the larger is equal to 1,215. So what is the volume of the smaller? So we'll have our V1 over V2, or they're saying V small over V large. That's fine too. Side 1 over side 2 squared, or no, sorry, cubed now because we're doing volume. So we have our volume of our smaller, we don't know. All right, that's our V1. Our volume of our larger is 1215. And we take that 8 over 27 that we got whenever we cubed our 2/3. Solve using cross multiplication. And you get a volume of 360 units. And it says be sure to include your appropriate units. So always remember, even if they don't give them to you, if they don't say inches or centimeters, you should always put units squared or units cubed when you're talking about area or volume respectively. And then last but not least is scale figures or scale drawings. They're two-dimensional, such as maps, blueprints, and diagrams. Then we have models are three-dimensional, so remember scale drawings, two-dimensional, models are three-dimensional. The scale of a drawing or model is the ratio of the dimensions of the drawing or model to the corresponding dimensions of the actual object. So that's what we've just been doing, but now we're actually going to put it into context. In a scale drawing or model, all the dimensions are in the same scale or ratio to the actual dimensions of the object. So example 5. A toy manufacturer makes scale model tractors with a 1 to 8 scale. If a model has dimensions of 17.5 inches by 11.25 inches by 11.5 inches, what are the corresponding actual dimensions of the tractor? So we have to remember we have a 1 to 8 scale. So a 1 to 8 scale would look like 1 over 8. So we're going to have to do this for each different side to find out the actual dimensions. So 17.5 inches is our small measurement. Obviously, because a tractor wouldn't be 17.5 inches. So we have 17.5 over x, which is our unknown for our actual. We'll call this the toy and the real one. And then we don't know how big the actual real one is, but the scale tells us that it's a 1 to 8, so that's our number that we're using there. And then we'll solve using cross multiplication. So x times 1, 17.5 times 8, and we get 140. So it's 140 inches, that's one measurement. Now we need to do the same thing for the 11.25 side and the 11.5 side. So we'll solve with cross multiplication. We get 90 inches. And for the third one, 11.5, using our cross multiplication again, we get 92. So the actual dimensions are 140 by 90 by 92 inches. So that's actually it for this lesson. Go ahead and take a look at your assignment and let me know if you have any questions.